Hello and welcome to today's class. So let's proceed. This is the second part to the study of capacitor. So I've done an introduction to capacitor in our previous classes. So try to get a video, or I'll drop the video link in the description of this video. So check the description of this video. You see a link to our previous class to capacitor. Let's proceed in the study of capacitor. So when it comes to capacitor, there are two things to note. So the first one is there is that when capacitors are arranged in series, they have the same charge value. That is, the charge that flow through them are the same. So when capacitors are arranged in series, in this form, this is a series arrangement. So for this series arrangement here, it means that the charge, that is Q in quote, the Q value, let's say Q is 4. It means that for Q1, Q2, Q3 in this circuit, there will be the same thing. Why? Because this circuit is a series arrangement. So I'm saying that when capacitors are arranged in series, they have the same charge value. That is, the charge, that is Q, that flow through them are the same. That's your first thing to note when it comes to capacitor. Number two, that says when capacitors are arranged in parallel, the same potential difference flow through them. This capacitor is not arranged in parallel. This is a series. This is arrangement. What of it is arranged in parallel? It means that their potential difference are equal. That is, V will be the same all throughout. So please bear this concept in mind when it comes to capacitor. All right, let's take a look at this example here and solve together. The question attached to this diagram here says, for this circuit shown below, that is this diagram, for the circuit shown below, comma, find the equivalent capacitance, comma, the charge and the potential difference across each capacitor. Find the equivalent capacitance, that's number one, the charge, that's number two, and the potential difference, that's V, across each capacitor. All right, let's get it done, please. So first things first, I have a circuit diagram here. I'm asked to find three things there. Number one there, I'm asked to find the equivalent capacitance. Number two, I'm asked to find the charge of each circuit, right, of each capacitor, and I'm asked to find what potential difference. So let's get it done, please. So solution. Some persons will come and say, because it's a series arrangement, just come and say 1 over 3 plus 1 over 12 plus 1 over 4. It's not done that way, because in this case here, you're not giving that C1 is this, C2 is this, C3 is this. So you have to label them first. So first is first, let C1 to be equal to 3 microfarad. Let C2 to be equal to 12 microfarad, and let C3 to be equal to 4 microfarad. So identify C1, C2, and C3. To get the equivalent capacitance, that's number one question. Let's get the equivalent capacitance. So to get that, obviously this is series arrangement, and for series arrangement of a capacitor, for series arrangement of a capacitor, what do we know? I have that 1 over equivalent capacitance is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Input your C1, C2, C3 into the expression. I'll have 1 over CEQ is equal to 1 over C1 is 3 plus 1 over C2 is 12 plus 1 over C3 is 4. All right, I have this place. Next task here, get LCM. Obviously, my LCM here gives me 12. So 12 in 3 gives 4. 4 times 1 gives you 4. Plus 12 gives you 1. 1 times 1 gives you 1. plus 12 4 gives you 3. 2 times 1 gives you 3. All right. From here, I'll have that 1 over CEQ is equal to this. From here, 1 over CEQ gives you about, this should be 8. So this is 8 over 12. All right, I have this place. 8 over 12. Next task there, I have to invert. I'll take this, I'll swap them to get CEQ value. So let's get CEQ. Perhaps from here, I can say that from here, invert. So this one comes up, goes down. I have CEQ over 1 equal to 12 over 8. 12 over 8. Obviously, I can reduce this. So 4 here gives you 3. 4 here gives you 2. So I have that CEQ value is equal to 3 over 2. So 3 over 2 microfarad. So the value for CEQ is 3 over 2 microfarad. In decimal form, it gives you 0.5 microfarad as the value for CEQ. So that's the first task. We also find the value for CEQ, that's equivalent capacitance. Number 2 says,
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen.
find the, what's it called? Number 2 says, hold on. Number 2 says, find the charge. So the charge for each capacitor. So let's get charges, please. So when it comes to finding charge, that's Q. So if I have C, if I have V, and I'm asked to find Q, what formula relates the 3 parameters together? So what formula relates the 3 parameters together? For the 3 parameters there, for the 3 parameters, okay, let's take which off. Correct. Take this off. So second part there says calculate for charges. So that's II, charge calculation. All right. For here, I will have that Q. Record that Q equal to what there? CV. We established this concept earlier that Q equal to CV. So I'm asked to calculate Q, right? So here's the concept. My C is simply my equivalent capacitance, which is 3 over 2, and that's 0.5, right? That should be around sorry, 1.5, please. All right. So in decimal form here, this will give 1.5, please. So it means that Q will be equal to C. In this case, my C, I have a lot of C. I have C1, C2, C3. I'm not referring to C1, C2, C3. I'm referring to the equivalent capacitance. So that's CEQ. That becomes CEQ dot V is a potential difference. This is now equal to CEQ is 2 over 3, and that's same as 1.5. So 1.5 microfarad times my V is my potential difference. That's 6. So that's 6. So my Q here will be equal to multiply 1.5 by 6. That gives around 1.5 by 6. Hold on, please. 6 or 16. Sorry, please. From the diagram, please. It is 16, not 6. 16. The V is 16. So I have to just change the value here as 16. All right, 16. 16. All right. So this gives you, obviously, we had 2 over 3 microfarad. So please, I need to attach the value of micro. Micro is 10 to the power minus 6. That's for EQ. E is EQ. CEQ. Then your V is 16. I have 15 here. So multiply these two, I should have about, for a point of calculator, I'll have about 2.4 times 10 to the power of minus 5 coulomb. So this is value for Q. So Q equal to 2.4 times 10 to the power minus 5 coulomb. That's Q. But I'm asked to calculate the charge for each capacitor. It means I have to get Q1, Q2, Q3 in this case here.
I just launched my website www.ghanaabukari.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website. Support our journey of this academic platform. Thank you guys, and welcome to my channel.
And I'm having Q as given here. But I gave you one thing to note. I said for capacitor arranged in series, their charges will be the same. So the same charges flow through them. So if I have Q as this, it means that my Q1 is this value, my Q2 is this value, and my Q3 is this same value. So I'm saying this place. For reference sake, I'm saying this place. I'm saying that we said earlier that Q now will be equal to what? Q1 will be equal to Q2 will be equal to what there? Q3. Why? Because we said for series arrangement of capacitor, we have the same charges flowing through them. As I have Q to be equal to Q1, Q2, Q3. So it means that my Q1 will be equal to what? This value 2.4 times 10 to the power minus 5 coulomb. Q2, the same value 2.4 times 10 to the power of minus 5 coulomb. Q3, the same value 2.4 times 10 to the power of what? Minus 5 coulomb. So I've gotten the charges for each capacitor Q1, Q2, Q3. The last part says calculate for their potential difference. That's V. So let's get the value of V. All right, let's get value of V. That's I. Let's get V. Let's get the value of V. So I says calculate for V, potential difference. What do we know? If we said Q equal to CV, if I want to make V subject here, I'll have that V equal to what there? Q over C. So I have Q over C. So it means that I will have to calculate the potential difference at each capacitor, right? So I have to calculate V1, V2, and V3 as I did for Q1, Q2, Q3. So in this case now for V1, so V1 will be equal to what? Q1 over C1. This is equal to what of Q1? Q1 is the value, that's 2.4 times 10 to the power of minus 5 all over C1. C1 is 3, so I have 3 microfarad, right? So 3 times, so 3 times 10 to the power what? Minus 6. This case, V1 gives me about, let's see what V1 will be. If I punch a calculator, all right. Let's get V1, that's 2.4 times 10 to the power of minus 5. So divided by 3 times 10 to the power of minus 6. This gives about 8 times 8 times 10 to the power of what? Minus 12. Potential difference is V. Alright, I've gotten V1. Let's get V2. So from here, similarly, V2 will be equal to what? Q2 over of course, C2. This is equal to what's Q2? Q2 is, of course, the same value. So I have 2.4 times 10 to the power of minus 5 all over C2. What's C2 there? That's 12. So I have 12. So if I divide this, let's get V2. If I divide this together, if I divide this, I should have that the value of V2.
Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both, right? So once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.
From that place, so V2 should be equal to, if I divide this, sorry, the 12 there is not just 12, but a micro there. So times 2 to the power minus 6. All right, divide this to 2.4 times 10 to the power of minus 5 divided by 12 times 10 to the power of minus 6. This is about 2 times. This gives 2 times 10 to the power of minus 12. Of course, without difference is V. So I've gotten V2. So let's get V3. Let's get V3, please. V3 will be equal to what there? Q3 over C3. These are equal to, what's Q3? That's of course 4. So I have 4 all over C3. Sorry. Q3 is this. That's 2.4 times 10 to the power minus 10 to the power minus 5 all over C3 is 4. I have 4 times 10 to the power of minus 6. So V3 will be equal in value to, let's punch, 2.4 times 10 to the power of minus 5 divided by 4 times 10 to the power of minus 6. This gives me 6 times 10 to the power minus 12. Alright, so this becomes your value for V1, V2, V3. So I've calculated for the capacitor, I've calculated for the equivalent capacitance. I've done for the charges and for the potential difference across each terminal here. That's V1, V2, V3, Q1, Q2, Q3, and also CEQ. Alright, this is a solved problem involved in capacitor involving a series circuit as shown on the board. Alright, one last thing to note before we leave.
Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.
Alright, in case perhaps in exam you're gonna ask to find for current, that's I. In case you're asked to find for current, that's I. How do you get I in this case, in this circuit? Of course, if I should, here's the concept. I have been playing with some parameters such as I've played with Q, V, and what's that concept, and C. These are like the 4 symbols I've been playing with so far, right? So let's say I'm asked to introduce I in this concept. What do you do? Some people will say from this V, we know that V from Ohm's law, V equal to what there? I R, right? But here's the concept. I can just introduce this stuff into these expressions here, right? Because I'm seeing R, and R is the resistor, and this is a capacitor circuit, not the resistor. So I can't introduce this idea into capacitor. So what do you do in this case? So when it comes to arrangement, perhaps when it comes to resistor and capacitor concept, the current there is given as V equal to IR, right? So there's a kind of Ohm's law for capacitor too. So capacitor has its own Ohm's law formula, which I'll be giving you now. So the so note something, please. Note Ohm's law for a capacitor. Note please, the Ohm's law for a capacitor. The Ohm's law for a capacitor is given by the equation below. The Ohm's law of a capacitor is given by the equation below. I equal to C into dV over dt. All right. So in case you are asked to find current when it comes to a capacitor concept, note that I equal to C in bracket dV over dt. This is basically from differentiation, that's calculus, right? So basically just note this formula, right? So let's say from the question I give you generally, from this question I gave you, I asked to find three things: charge, potential difference, and the we have to find the charge, potential difference, and the equivalent capacitance. Let's introduce I. So here's the concept. When I ask to find the current, they will always give you time, right? And your time should always be in seconds. If the time given is in minutes, convert to seconds. If the time given if the time given is in hours, convert to seconds. Please always convert to seconds. So when it comes to current, they will always give you time. So let's say for instance now we have to solve for question 4. That's 4 now. Such that we are given that we are asked to calculate for I given t as 30 seconds. So we are asked to calculate for current now in this case. What do you do? What do you know? We know that I equal to what? C into dV over dt. My C is not just ordinary C, is my C equivalent. So I'll have that C equivalent is equal to what? I equal to C equivalent dot dV over dt. This is now equal to I equal to C equivalent. We said is what? Around 1.5 as we did it initially. So 1.5 microfarad, right? That's 10 to the power minus 6 as value for EQ. Now the V over the T is always got when you're given an equation. In this case here, I'm not given an equation. So in this case, the V here signifies 16. All over the T here signifies the time. So I just have to put in the bracket, the V is 16. 16 over time there is 30. 30. So I have this place. Work on this. Let's get I. Work on this. Let's get I. From here, I, which is current, will be equal to divide these two first. If I divide 16 by 30, so I'll be having 1.5 times 10 to the power minus 6, right? Multiply by 16 divided by 30, I have about 0.533. Multiply these two together, high current will be equal to 1.5 times 10 to the power of minus 6. This gives about 1.2 times 10 to the power of minus 12. Please, current is measured in what? Ampere. That's A. So this becomes how to find current in the study of capacitor. Alright, this is how we solve problems of this nature. See you guys in our next class.